Dear students, Assalamu alaikum. Today we are going to discuss short questions of the exercise of chapter number 3, which are given in short syllabus. So first question is 3.9. The statement of the question is define impulse and show that how it is related to the linear momentum. Means we have to define the impulse and we have to write a relation between linear momentum and impulse. As we have already discussed in our class time, impulse is actually defined as the product of the force and the short interval of time for which force x is called impulse. The quantity F cross t is called impulse of the force, where F can be regarded as the average force that acts during the time t. So this is the definition of impulse. And the relation between impulse and linear momentum is that impulse is equal to F cross t, and this is equal to mvf minus mvi, which is actually change in momentum. So this is link between impulse and momentum. So next question is 3.10. State the law of conservation of linear momentum, pointing out the importance of isolated system. Explain why under certain conditions the law is useful even though the system is not completely isolated. In this question we have to define the law of conservation of momentum, and we have to show that if a system is not completely isolated, अगर एक सिस्टम मुकम्मल तौर पे isolated नहीं है तो उसके लिए law of conservation of momentum को हम कैसे यूज कर सकते हैं. So the statement of the law of conservation of momentum is, for an isolated system, total linear momentum of a system remains constant. So this is the statement of law of conservation of momentum. The total linear momentum of an isolated system remains constant. The other definition or the expression is total linear momentum of an isolated system before the collision is equal to the total linear momentum after the collision. Second part of the question is that if a system is not completely isolated, then what can we say about the law of conservation of momentum? So if the applying force, if the external force on the isolated system is very small as compared to the forces between the two bodies, then we may say that the force, external force, if the external force is weak or very small, so it can be ignored and we can still say that total linear momentum of the system remains constant, or law of conservation of momentum holds. The next question is 3.11. Explain the difference between elastic and inelastic collision. Explain how would a bouncing ball behave in each case. Give postulate reasoning for the fact that kinetic energy is not conserved in most cases. इस क्वेश्चन में हमें इलास्टिक और इनइलास्टिक कोलिजन के दरमियान फ़र्क को बताना है, और हमें यह बताना है कि वो कौन सी वजूहात हैं जिसमें जब एक बॉल को हिट किया जाता है ज़मीन फर्श पर तो वो उसकी जो काइनेटिक एनर्जी है वो मोस्टली कांस्टेंट नहीं रहती, एंड द कोलिजन बिकम्स इनइलास्टिक. सो द डेफिनेशंस ऑफ इलास्टिक एंड इनइलास्टिक कोलिजन आर गिवन एज a collision in which kinetic energy of the system is not conserved is called inelastic collision. एक ऐसा collision जिसमें सिस्टम की kinetic energy जो है वो कंजर्व ना रहे उसे हम कहते हैं inelastic collision. While an elastic collision is that in which no kinetic energy is lost, or we can say that kinetic energy of the system remains conserved. So the difference between the two collisions is that in elastic collision kinetic energy remains conserved, but in inelastic collision kinetic energy of the system doesn't remain conserved. but momentum, as we know that momentum in both cases remains conserved. So these are the definitions or the difference between the elastic and inelastic collision. And next question is, when we throw a hard ball or ball on the floor, why kinetic energy is lost? So because the kinetic energy is lost due to the air friction, due to the friction between ball and the floor, and some of the energy is converted into the sound. So that's why kinetic energy of a ball hitting the floor doesn't remain constant. So that's why we can say that it is a type of inelastic collision. But if these energy changes like the friction or the sound energy is very small, then we can say that this is a type of elastic collision. So next question is 3.12. Sorry, this has been done. 3.13. Explain what is meant by projectile motion. Derive expression for the time of flight and range of projectile, and show that the range of projectile is maximum when projectile is thrown at angle of 45. So this is a long question, a type of long question. इसमें हमें projectile motion की definition के बारे में बताना है, and we know that two dimensional motion under constant acceleration due to gravity is known as projectile motion. So this is the definition of projectile motion as we have earlier discussed in our class. So next is the time of flight and range of projectile, and show that at which angle we have to show that the range of projectile is maximum at angle of 45. This is the range of projectile. Maximum distance which a projectile covers in the horizontal direction is called the range of projectile. Now, range of projectile can be obtained by multiplying the velocity along x-axis and the time of flight. And we know that the velocity, initial velocity of the projectile was vi cos theta, that is along the x-axis, and the time of flight was 2 vi sin theta over g, and when we solve this, so r is equal to vi square over g into 2 sin theta cos theta. So this is the range of the projectile. The range of projectile can also be written as r is equal to we can also write the range of projectile as we know that 2 sin theta cos theta is equal to sin 2 theta. So range of projectile can also be written as vi square over g into sin 2 theta. The last portion of the question was that we have to show that the range of projectile is maximum at angle theta is equal to 45. So in this expression, if we see that we have projected a projectile with velocity vi and acceleration due to the gravity g, so these are the constant for a particular case. So the range is maximum when sin 2 theta has maximum value, and the sin 2 theta has maximum value of 1. So we have to place sin 2 theta is equal to 1, and sin 2 theta is at only 1 at the angle 2 theta is equal to 90. If 2 theta is equal to 90, then sin 2 theta is 1 and theta is 45. So we can say that the theta at the theta 45, the range of projectile is maximum. So next is the time of flight. So the time of flight is the time taken by the projectile to cover the distance from the place of its projection to the place where it hits the ground. So as we know that projectile motion is this one, like this one. So the time taken by the projectile from the point of projection and the point of landing, so this time is known as the time of flight. This can be achieved by second equation of motion, because the distance covered along y-axis is 0 at the both points. So s will be 0, height will be 0, Vi, because we are dealing along the y-axis, so the velocity component will be along the y-axis. This is Vi sine theta multiplied by t, minus sign is because we are throwing the projectile in upward direction, so g will be negative. By solving this equation, we can find the time of flight by t is equal to 2 Vi sine theta over g. So this is the question number 3.12. So next is question number 3.13. Question 3.13 is that at which points the projectile has its minimum and maximum velocities. So the velocity is maximum at both 2 points, at the point of projection and the point of landing. At these 2 points, velocity of the projectile is maximum, but at the maximum height, because the vertical component of the velocity becomes 0, so the only component remaining is x component. So at maximum height, velocity becomes minimum, because Fy component becomes 0 and V only becomes equal to x component of the velocity. So the answer of the question is that at the point of projection and the point of landing, velocity has maximum value, but at the maximum height, the velocity has its minimum value. So these were the questions in the exercise of chapter number 3, which we have completed in this lecture. If you have any question, you can ask. Thank you very much. Inshallah, next lecture we will start chapter number 4. Thank you very much.